So, hello everyone, looking at natural logs and exponentials. I will do number 1 to number 8 because number 9 is very long and I have two other tests that I need to prepare for today. So, let's get into these logs. Alright, so let's just get something out of the way one time. And I sure saw highlighted this in the last class. ln x is equal to 1 over x, and e to the x is equal to e to the x. So when you differentiate this, your dy dx is equal to this. When you differentiate this, dy dx is equal to dy upon. Alright, this right. ln x, when you actually dy upon dx, you're going to have 1x. And e to the x, when you dy upon dx, is equal to e to the x. So just keep that in mind as we go along, because I think I now understand why some persons don't think maths is their friend. I had to do a lot of, I can't say mastered algebra, but logarithms and exponentials are not really my comfort suit because they don't follow the natural order that we're accustomed to. Alright, so let's start off. Y is equal to, let me just check before I proceed, ln x cubed. ln x cubed. Now, like all the other videos, it's the pattern that I'll be focused most on, so pay attention to the pattern. We know that, as even I said it, ln x is equal to, after differentiation, 1 upon x. So what this actually now tells you is that you're going to put 1 being divided by something. So if ln x is 1 over x, ln x cubed is going to be 1 over x cubed. And after that, you multiply by the derivative of here, which is going to be 3x squared. So this is going to be 3x squared divided by x cubed. And I'm just going to work this out for this particular one. Afterwards, I'll just do it as per normal. So 3 of x. Law of indices, people. Just keep that at the back of your mind as we work through it. Alright, next one. Next, alright, good. So this one is e raised to the 2x cubed. So e raised to the 2x cubed. Alright, now this seems scary when you look at it first, right? So writing back again, e to the x, when I dy dx, I'm going to have e to the x. So dy upon dx, you write back what you were given, e to the 2x cubed, and then of course you differentiate what's there. So this is 6x squared. So this is going to be 6x squared, number of course in front, e to the 2x cubed. And you're finished. So again, you just rewrite whatever you're given, differentiate the power, and just make it look neat afterwards. Next one, ln 2x raised to the 4th, or 2x to the 4th power. Alright, now this is where things become thingamajig. So let me go into a whole new page. At 25. Alright, I got enough page left back. So y is equal to ln 2x to the 4th. I'm spacing it out for a reason. Alright, so dy upon dx. So again, I'm going to write this again for you. ln x is equal to 1 upon x. So you could take this in that this here is another part by itself. So you'd have 1 being divided by ln of 2x to the 4th, right? So that's one component that you just completed. I need to actually switch between colors so you'd understand this part, so just bear with me a bit. So next now, I have this to deal with. So what I'm looking at now is ln 2 2x to the fourth power. So in actually writing that now out, again it's an ln, so it's 1 on top, and whatever else remaining goes at the bottom. So I have 2x to the fourth. And let me change color one more time. Give you red. So this is now multiplied by this. So you're looking at 2x to the fourth, which is going to be 8x cubed. So this is 8x cubed. So going back to my shade of blue. Good. So this is now equal to what's on top? It's 8x cubed being all divided by, let me write it neat. I would say let's write it neat because there are certain things you just need to pay attention to. So this is 2x to the fourth ln 2x to the fourth. So 2 1s 2, 2 4s 8, and put a multiplication here. So this 3 gone, this is 4 take 3, which is going to be equal to 1. So what that now tells me is I have 4, because remember all these x's are gone, 1 is at the bottom, being divided by the 1x, and then you have ln 2x to the fourth. Just remember this particular spot right here. Like that's the most important thing to pay attention to. Everything else could just fall into place afterwards. And in most cases, of course, you will have to be canceling. Next one is ln 3x cubed. So it's very similar to what just happened. So I have ln 3x cubed, and this is y. So dy upon dx is equal to 1 over ln 3x cubed times 1 upon 3x cubed times derivative of here now, 3 3 is 9, x squared. So this is now 9x squared being divided by 3x cubed. Put a little multiplication there for simplicity. ln 3x cubed. Now you're not supposed to actually write it like that as you saw in my answer before, but it's just to highlight that what's in front here is what you're actually using to cancel what's up here. You just leave this as is. So 3 1s, 3 3s, these will go. So I'll have 3 minus 2, which is going to be equal to 1. So what I'm left with is 3 being divided by x ln 3x cubed. Yep, that's it. All right, so you see these are not difficult. It's just remembering what to do and how to do it. All right, so now this is a combination trig ln 4x cubed. All right, so let's go straight into it. So y is equal to cos ln 4x cubed. So dy upon dx is equal to derivative of cos, like I said before, use a table, which is going to be minus sine, and you write back your ln of 4x cubed. Now this is going to be multiplying ln, so remember this again, ln x is equal to 1 over x, so this is going to be 1 over 4x cubed, which is now times by derivative of this 12x squared. So what you're now having is this and this are going to multiply, and 4x cubed is that actually at the bottom. So you're going to have minus 12x squared sine of ln 4x cubed all being divided by 4x cubed. Now don't get fooled. This here is special. So just focused on this here to work with this here. So 4 1s, 4 3 is 12. This goes, so 3 take 2 is 1. So now we have minus 3 of sine ln 4x cubed, all being divided by x. Yeah, that is it. I know this one is actually a little bit difficult, but just follow the steps and again, follow the pattern. Patterns are what you need to actually follow right now for those persons that know who I'm talking to. Alright, so next one, number 6. Oh, this one is very, very funny. Y is equal to e to the 3x squared. So y is equal to big E, small e, and small e has a power of 3x raised to the square. So e to the, alright, so just reminding you again, I really need to download back my software. E to x, when you find the derivative of that is e to the x. So dy upon dx is equal to, write back what you were given, e to the 3x squared times, now you have e to the 3x squared. So you're going to write that now, e to the 3x squared. And now you're left with 3x squared, which is going to be 6x. So this is 6x. So what you're going to be doing now is write 6x. Now noticing that you actually have similar bases, what you're going to do now is you're going to have e to the, what it was, the power is what you're going to focus on now. So you're going to put a bracket, and in the bracket you're going to put the first one, which is e to the 3x squared, and you're going to put plus 3x squared. Alright, I honestly didn't check this one, let me just take a little peep at number 6. Huh. Yep, that's it. That is it. 6x times e to the well, I put in bracket for my own personal reasons, like I always say, because sometimes it's good to actually understand exactly what you just wrote down. Alright, I think the next one is supposed to be similar to that one. Yeah. So you have e raised to that power there. So this is actually a lot to take in for number 7. So y is equal to e bracket 4x cubed plus 5 close bracket squared. So dy upon dx, you write back what e to the x is, in this case e to the 4x cubed plus 5 squared. Now you have 4x cubed plus 5 squared, which is going to be 2 4x cubed plus 5 times 3/4 is 12x squared. So you just use your normal chain rule there. So 12 times 2 is going to give me 24x squared. And then we have 4x cubed plus 5. So I just did everything. So let me just here, 24. For those that probably missed that jump. Alright, now this is where things become what it is. So I don't know the exact structure of how this is written, so I'm going to write it how I actually believe I was told I should write it. Let me see how they have it. If they have it the same way, yeah, they have the same way I have it. So I was told you put it's all going to be, it doesn't really matter, but I believe when we do more calculus, it has its own rules to follow. So you have 24x squared, that's here. You write your e with your power. and then you write your bracket. Again, I don't know if this is a hard and fast setup for any particular reason, but this is the structure I was told that I should have the answer written in, and the worksheet has it written in the same way. Alright, so this is the last one that I'm actually going to work, which is going to be number 8, number 9, and 10 is going to have to come afterwards, because, yeah, it's a lot. So y is equal to ln 4x squared times minus x cubed minus 4. So y is equal to ln 4x squared, that means multiply, minus x cubed minus 4. So right away this is a uv situation. So u is equal to ln of 4x squared. So du upon dx is equal to 1 over 4x squared times 8x, which is equal to 8x over 4x squared. 4 1's 4, 4 2's 8. This goes, that makes it have 2 over x. That's u. And now for v, this is equal to minus x cubed minus 4. So dv dx is equal to minus 3x squared. So remembering that we have to follow the product rule, so u dv dx plus v du dx. So u ln 4x squared, ln 4x squared, dv dx is minus 3x squared, plus, I think I'll just do the advanced method for this one, because yeah, this is going to be minus x cubed minus 4. I'll show you a little bit of how mathematicians dunk on these type of questions at certain points. Alright, so this is my dy dx. That's what it's equal to. Now, at this particular step, what you can do is you just expand the brackets. So this is going to be minus 3x squared ln of 4x squared, right? And I'm using this for a reason. You'll see why just now. And here we have 2 divided by x, which is multiplying this. So expanding that, it changes. No, I like it leaving my signs like the way they are. This minus 2x cubed minus 8, all being divided by x. Now, in order for you to actually simplify this, what you would actually do is you would just say divide here now by x as well, in order to quote unquote make life easier. So, but using that knowledge, alright, so yes, using that knowledge, don't say that. This is going to be divided by 1. Sticking to, shouldn't be divided by x, it be divided by 1. So, yeah, maybe I shouldn't talk fancy, I should just stick to what I can actually explain easier. Now, when we actually work this out fractionally, we do remember that this is going to be what it is. So this is going to be minus 2x cubed minus 8. And here, because the LCM is 1 and x, this is going to be multiplied by x. Now, this multiplication is only going to be applicable to minus 3x squared. ln 4x squared is untouchable. So this is going to be minus 3x cubed ln 4x squared, which is all being divided by x. And you're finished. So at this particular step, depending on what you actually get, knowing that this is x and c divided by 1, you write back what's there, and for the other one, you just multiply it by whatever the LCM should be. I didn't really talk it the advanced way, but let me just check and make sure this answer is correct. Minus 3x cubed ln 4x squared. Yeah, and that's it. Yeah, this may be the last one I actually work for today. I don't think I'll actually have more time to do any other work, but I'll still post later on. With that being said, I hope everyone have some fun with the test. Bye.